Okay, so we learned previously how to find the table of values, right? How to punch in the numbers into the x to find a y using table of values. And then we've also been talking about the slope of the line. Can you guys remind me what's the formula for the slope of the line? M equals rise over run. It's also y2 minus y1 over x2 minus x1. So we use both of these, right? So we're going to see how can we, if we have the table of values, how can we use that table of values to find the slope of our line. Okay? So a table of values is a table used to record the coordinates. Coordinates means the x and y value of points in a relation. So a relation is a pattern that connects two sets of data. What does it connect? What letters have we been talking about? X and Y. X and Y. So when you're looking at a point, you're looking at the x and the y value of the points, right? Yes? Okay. We call them, do you remember what the word that I used for the x and y? Like when I put x and y in brackets, like this. Remember what word I used? Ordered pair. Okay, it's called ordered pair. Right, pair means two. Okay. What would be the shape of a linear relation if you want to graph it? How does it look like?
Horizontal group.
It could be also diagonal, right?
Oh, yeah,
but what do we call them? Diagonal what? Horizontal what? Lines, so it's a straight line, right? So it's a straight line. So a linear relation is a straight line. The slope is the rate of change. So we talked about this. There's few names that they use for the slope. So they're going to use the slope. They're going to use the rate of change. It means the steepness. So it's the rate of change. There's an E, yeah, thank you. Of, that's not an if, that's an of. So it's the rate of change of one point on a line in relation to the other point on the line. So when you're looking at the slope of the line, you're going to ask yourself, how much is y changing for every 1 unit of change for x? So how much is y going up by for every unit of change for x? Remember, it's rise over 1. So as x increases, if y also increases, the slope is positive or negative? Positive. Because as x is increasing, y is increasing. So this is the y value, and this is the x, right? As x is increasing, y is increasing. So that brings me into a line that goes like this, right? And a line that goes like this have a positive slope. So let's look at it this way. So in this case, x is increasing, so as y is increasing, right? Both x and y are increasing. As x increases, if y decreases, then the slope is negative. And then it's going to be a decreasing line. case, you see that x is increasing, and at the same time, y is decreasing, it's going down. Okay, so we're going to use the table of values to determine the slope, which is the rate of change, the difference between the successive y coordinates for the relation 3x plus 1. I just have a question for you guys. Looking at the equation, tell me what the slope is. The slope is 3. Remember, we talked about it when we did the table of values, and we found out after we drew it that your slope is the same thing as your coefficient of the x. So technically, I know what the slope is, right? But if they did not give me an equation, they just gave me x and y values, I need to be able to find the slope. Okay? So let's do this. Let's find the table of values first. So what do I plug in for x?
0.
0 in this case. So 3x, instead of x, you're going to plug in 0. 3 times 0 is?
0.
Plus 1? 1. What would I plug in for this? So what would be my point?
4.
What would be my point here?
0.
0, 1. Excellent. What do I plug in for my second one? 1. So 3 times 1? 3 plus 1 is 4. And my point is going to be 1, 4. And then I'm going to plug in 2, because my x value is 2. 3 times 2 is 6. Add 1, that's 7. And my point is going to be 2, 7. For the fourth point, I'm going to plug in 3. So 3 times 3 is 9. Add 1, that's 10. And my point is going to be 3, 10. It is increasing by 3, right? And then my next point is going to be 3 times 4 plus 1, so that's going to be 13, and my point is going to be 4, 13. Now, rate of change, which is the slope. What does the slope tell you have to do? Give me the formula for the slope. What's the formula?
X1.
No, y2
Minus y1.
over
X2.
minus x1. Okay? So, y2 minus y1 over x2 minus x1. That's the formula. So the slope is y2 minus y1 over x2 minus x1. Now, if you look at this, right here is your y2, right? This is your second y, and then this is going to be your y1. Okay? So I'm going to do 4 and then take away 1 from it. Make sense? So it's going to be 4, take away 1, divided by, what would be my x2? Where's your x value in this point? 1, take away 0. Okay? So the y from the second point minus the y from the first point, divided by x from the second point minus the x from the top point. Okay? So that's going to be 4 minus 1 is 3. 1 take away 0, that's 1. So what's 3 over 1? Just 3. Okay? Now we're going to take the second set of points. Okay? So now we're going to go with these 2 points. You always move from the bottom to the top. Okay? So what would be your y2? What would be your y2? Y2. So the bottom one. Bottom. What is it? 7 minus 4 over 2 minus 1. Perfect. 7 minus 4 is 3. 2 minus 1 is? So So 3 over 1, which is 3. Okay? So you start from the bottom to the top. Next one. What will be my y2? 10 minus over 3 minus 2. Perfect. 10 minus 7 is 3. 3 minus 2 is 1. So it's going to be 3. They have to be. Otherwise, you've done a mistake. We know it's a linear function. We know that this is linear. We've already discussed that it's a linear function. The slope has to be the same. Otherwise, that means you have done something wrong. Go back and check your work. Okay? Now, we only can do one more. Okay? We can only do one more, which is taking this minus the top one. Okay? So it's going to be 13, take away 10, over 4, take away 3. That's also going to be 3. Okay? And we already discussed what the slope is going to be. What did we say the slope is going to be? 3. Did we find that also here? Right? So there is a match between this and your slope, the coefficient of the x. Are you guys okay with this? All right. So if the slope is the same for all coordinates, then the rate of change is constant, then it's a straight line. So if you get that all of the slope are the same, we call it constant, we know right away that this is a straight line. So here is what you're going to do right now. You're going to fill out this, and then you're going to find the rate of change.